On the axes below, sketch the graphs of y equals x times 4 minus x and y equals x squared times 7 minus x, showing clearly the coordinates of the points where the curves cross the coordinate axes. So first we have a quadratic here. We've got a root when x equals 0 and another root when x equals 4. If I were to expand this out, I would get 4x minus x squared. So the fact that it's a minus x squared is telling me it's going to be an N shape rather than a U shape. So it's going to look something like this. That's not drawn very well. There we go. Right, let's now draw the x squared times 7 minus x. So we've got a repeated root at x equals 0. I know it's a repeated root because of the squared there. And then we have another root at 7 because of the 7 minus x. If I were to expand this out, I would have 7x squared minus x cubed. So the fact that it's a minus x cubed is telling me it's going to be this shape rather than this shape. So drawing this in, I'm starting going down. I've got a repeated root at 0, so it's going to stop there and start going back up again. And then it's going to come down through at 7 like that. It will intersect again down here, because the x cubed will always become bigger than the x squared eventually. So I do just want to make sure that I show that on my graph that they will intersect down there. So there we go. I've drawn both those curves onto the axes. I've shown where they intersect on the coordinate axes, so that's part A done. Part B. Show that the x coordinates of the points of intersections are given by this equation here. So points of intersections are where we do simultaneous equations. So I'm going to take my two curves and make them equal to one another. Let's expand those brackets. So I'll get 7x squared minus x cubed is equal to 4x minus x squared. I'm now going to add x cubed to both sides, and I'm going to subtract the 7x squared from both sides. Which gives that. I can now factorise an x from each of these terms. And we can see that is what I needed to show. We're then told that the point A lies on both of the curves and the x and y coordinates of A are both positive. We need to find the exact coordinates of A, giving our answers in the form stated there, the p plus q root 3 and the r plus s root 3, where p, q, r and s are integers. And calculator methods are not allowed for this question. So, well, I can see that the points are going to intersect, the curves are going to intersect at 0, 0, which obviously we're not interested in if x and y have to be positive. They're going to intersect again here, and like I said before, they're going to intersect again down there. But we're not interested in that one because the y coordinates down there are negative. So we're interested in this point here. Right, so the solutions to this equation would be either x equals 0 from here, which again we're not interested in because that's that point, or this quadratic could equal 0. We can't use a calculator for this, so we're going to have to complete the square. So x minus 4 all squared, that's just halving the 8. Take away the 4 squared, and not forgetting the plus 4 there. The minus 16 plus 4 is minus 12. Let's now add 12 to both sides. We can square root. So we'll get plus or minus the square root of 12. Root 12 is the same thing. Root 12 here is the same thing as 4 times 3. Root 4 times 3, which we could simplify to be 2 root 3, because the square root of 4 is 2. So we could replace this with 2 root 3. All we need to do now is add 4 to both sides. So we're finding that x is either equal to 4 plus 2 root 3 or 4 minus 2 root 3. I just need to think about which one of these it's going to be. Remember that these two answers are telling me the points of intersection. So one of these corresponds to this point here, the other one corresponds to this point here. We're not interested in this one because that's when the y coordinate is negative. So I'm not interested in the bigger version of these. The x coordinate here is obviously bigger than the x coordinate here. So I'm not interested in the bigger one. I want the smaller one of these. So I don't want the 4 plus root 2. I want the 4 minus 2 root 3. That's the one I want. So just to repeat that logic, I've got 4 plus 2 root 3. That corresponds to the x coordinate there, because that's the bigger of the two x coordinates. 4 plus 2 root 3 is bigger than 4 minus 2 root 3. So this point here is the 4 plus 2 root 3. This point here is the 4 minus 2 root 3. And that's the one I want, because that's the one that's going to give me the positive y coordinate as well. So if I now take my 4 minus 2 root 3, to work out the y coordinate, if I substitute that back into either of my original equations, I think it's going to be easier to substitute it into the original quadratic. The original quadratic was y equals x times 4 minus x. So if I substitute that in here, 4 minus 2 root 3 multiplied by 4 minus 4 minus 2 root 3. So 4 minus 2 root 3 multiplied by the 4 minus the 4 is 0. So 4 times 2 root 3 is 8 root 3. The minus 2 root 3 times 2 root 3 is minus 12. So my x coordinate is 4 minus 2 root 3. My y coordinate is 8 root 3 minus 12. So just to write that as a coordinate, because that's how the question's got it written here, let me write that in the exact same form. We'll have 4 minus 2 root 3, and then we'll have the minus 12 plus 8 root 3. There we go.